Okay, guys, welcome back. So on page 53, we're still talking about transformations, and today we're going to take a step into dilations, which we've talked a little bit about. Now, this word dilations is, if you would, draw an eye to the best of your ability, and you can give it little eyelashes, because this word dilate is similar to the word that says that your eye dilates. That's what happens to your eye. It dilates. It either gets bigger or smaller to adjust to the light. It happens all the time. It's constantly happening when you go into a dark room versus a light room, or you go outside versus inside. Your eye is dilating. It's either getting bigger or it's getting smaller. And in math, specifically 8th grade math, we say, we say bigger. Let's go ahead and say that. Bigger or smaller. We use the word enlargement or enlarge versus reduced. And then let's draw an arrow like this and say turn page. So bigger or smaller, we use the words enlarged versus reduced to talk about it getting bigger or smaller. I want you to draw an eye to, just to remember that, hey, this is the word dilate. And we're going to turn the page and continue our information about dilations. Now, on this page at the top, we can write dilations, and in parentheses write the word continued. And this is actually number 4, dilations continued. And in dilations, there is something called a scale factor. And that scale factor has a nickname called K for short. And that K is determined by a very simple fraction called new over old. And after you write new over old, I want you to put a little apostrophe after new to remember that new is the one with the prime letters. It has a rule. Let's go ahead and write that rule up here. The rule is xy. For each xy, to dilate them, to make them bigger or smaller, we're simply going to use k. K times x and k times y. So the rule for dilation is any coordinate point in a particular image, xy, can be enlarged or reduced by this number k. Let's take out our assignment for today. The assignment for today is talking about how do we determine this scale factor k for each dilation. A scale factor is simply a fraction that represents how much a shape or figure is, these are the words we talked about, enlarged or reduced. It has a nickname K, which is simply new prime over old or original. So for each one of these examples, you can see that I have a new and an original, and I've labeled these new and an original. So we need to give it the points. If this point up here is A, its corresponding point here is going to be A prime. If this point is B, its corresponding point in the new image is B prime. And same thing with C prime. Now we practiced this a little bit new versus old, and actually we used the images, or we used the fractions small over big, and we're going to use that same methodology here to determine what the scale factor is and actually find the missing side. So we can use either set of matching sides. Let's use A to B is A prime to B prime. We're simply going to create a fraction new over old. So we're using the corresponding sides, the matching side length of B prime to A prime. And the reason this is going to be the numerator is because this is the new. So we take that number 6 and we use that as our numerator. And we're going to take the length of the corresponding side A to B, which is 3. So therein lies the question, how many times does 3 divide into 6? The scale factor for this particular situation is 2, because each one of these side lengths gets doubled. The 6 gets doubled to get to 12, the 3 gets doubled to get to 6, and therefore we can determine x, which is A prime to C prime, by simply doubling the original side length AC. 2 times 7, the missing side is going to be 14. Let's look at the second example. Again, I've got new versus or the original or old. So I want to go in and I want you to put in the prime. This is L prime, M prime, N prime, and P prime to make sure that we've labeled the corresponding points appropriately. Now this time, I want you to notice what's different from this situation to this situation. This triangle went from small to big. In this situation, we're going from a bigger triangle to a smaller triangle. I want you to notice what happens. We're still going to use the same formula, new over old, and we're going to have to use a side that actually gives us information. There's only one set of corresponding sides that gives us, or one pair of corresponding sides that gives us information, and that's M to N and M prime to N prime. It's very important that you get your numerator in the right place and your denominator in the right place, because we're going to use new first, which is 3, M to N, over old, which is simply M to N, 3 over 9. Now we get to use our 7th grade skills. Can this fraction be reduced? Yes. To 1/3. Good. So in this case, my scale factor in its smallest form is 1/3. How do I know that? Because I already know that these are been told me as similar. I've used my matching sides, the information that's been given to me, and I've got my numerator in the right place and my denominator in the right place. So I've got new over old, that's 3 over 9, which reduced to 1/3. So if that's the case, if this is my scale factor, I want to compare, let's use a squiggly line to compare the line P to N versus P prime to N prime. If I need to determine the value for x, the length of P prime to N prime, I'm simply going to use my scale factor of 1/3. 1/3 times 12 is going to give me 4. So the one thing that I do want to point out, and let's go ahead and draw a little arrow, and let's point out that the differences that took place in example number 1 and number 2. And I promise you, this is going to give you one answer on the star. This is the secret to one answer on the star. It happens every year with about 99% certainty. I can tell you right now, if you understand this point, that when my when my images go from small to big, my scale factor is greater than 1. It's 1, 1.1, 1.2, 2, 20, 2,000. It's something greater than 1. In fact, let's just write k is greater than 1. When it goes from big to small, that means I'm reducing. My k is going to be less than 1. For today, I simply want you to complete these sentences. So the new object here, as we've been talking about, is going to be A prime, B prime, C prime. And since I went from A, B, C, did it get bigger or smaller? It got bigger. But I want you to use that right, this word enlarged. By a scale factor of, now we need to determine using our corresponding sides, what is the scale factor. So we're going to write k equals new over old, new prime over old. And let's use these sides, B to C. How would I determine the length of B to C? Well, in here, you actually are just going to count. From B prime to C prime is 2, and from B to C is 1. My scale factor for this particular situation is a scale factor of 2. And since I can count and see that A to B from here to here is 1, then X is simply going to be 2 as well. Let's do number 2 together. So the new object identified is going to be right here. I can see where my primes are, so I can see it's going to be A prime, B prime, C prime, and D prime. Did my shape get larger or smaller? It got smaller. What's the word for smaller? Good, reduced. And now we have to determine by how much did it get smaller. Let's write k equals new prime over old. And this time let's actually write the side length. Let's use this top. This is the easiest one to identify. Let's write the line B prime to C prime over the old B to C. The length of B prime to C prime is 2, and the length of B to C is 6. Which can be reduced to 1/3. And if my scale factor is gone from 1/3, my missing side, 3 times 4 is going to be 12. It's multiples of 3. This will be assignment number 1. You can go ahead and put a circle for your grade right here. Make sure you complete 3, 4, 5, and 6 on the back, and we'll grade it when we get here tomorrow.